Right. The second part of 9.2 is graphing quadratics when they're in factored form, and then also using factored form of a quadratic in some real-world problems. These problems can get tough. There's a lot of steps involved, so be patient with yourself as you're learning the real-world problems in this section. You can do it. It's just going to take some deep thinking. All right, so we're going to start with this one. We'll do this one together, so try to follow along. You don't have to write as you're following along, just try to understand the process. You'll have a chance to write the next one down. So we have a museum vault, and it has a thick wall around it because it's a museum vault, so we want to protect our stuff. The interior of the vault is 40 feet long, but it has this thick wall, and we don't know how long the thick wall is. So the thick wall we're going to call X. So this is 40 for the main part of the room with an X on each side. So that means that this dimension with the with the wall, would be 40 plus 2x, one at the top and one at the bottom. The other dimension of the vault is 20 feet, but with some x's at the top and the bottom again. So there's an x here. We don't know how thick that is, so we're calling it x. And so this dimension is 20 plus 2 x's, one on the right and one on the left. If I want to know how big the whole vault is, I would need to do length times width. So I would do 40 plus 2x times 20 plus 2x. I forgot the x. And the problem tells me that the whole museum vault is 1,664 square feet. So we're going to try to solve this for x. We have an equation now, so we get to figure out what x is. You can multiply this out either by distributing or by making a box. I'm going to distribute and show you that process, but if you are more comfortable making a box, you can certainly do that for these problems. So now I have to distribute again, so I get 800 plus 80x plus 40x plus 4x squared equals 1664. I'm going to write this in standard form, and I have 4x squared plus 120x, and as I write this in standard form, I'm going to subtract because I want this to be equal to 0, so I get negative 864, and that's equal to 0. Now quickly I notice that if I divide everything by 4, I would get nicer numbers, smaller numbers to work with. And since all of these numbers are divisible by 4, I'm going to go ahead and do that. You're allowed to divide both sides of an equation by 4. It doesn't change your equation. So we're going to go ahead and do that. So we have x squared plus 30x minus 216 equals 0. So now we've gotten ourselves to another standard form equation, and this standard form equation is factorable, so we're going to look at factoring this. As you can see, it's a lot of steps. Now we have to factor this new thing. So we started off kind of in factored form, and now we're going to go back to factored form again, but with different numbers. So remember, for this, our product is going to be a times c, which is negative 216. Oops, I wrote that down. 216. And our sum is going to be c, which would be positive 30. It might take a lot of guess and check for you to get this. If I tried 4, and I'm actually going to do negative 4, that would be 4 times 50, 4. And that adds up to 50, so that doesn't quite work. So I'm going to try negative 6, and it turns out negative 6 times 36 gives me 216, and that also adds up to 30. Probably you're not going to find it that quickly. I have already seen this problem, so I was able to find it that quickly, but you just keep trying numbers until you get numbers that work out. So then you have x squared minus 6x plus 36x minus 216 equals 0. You can go to a box at this point, or remember you can factor, you can do distributive, undoing distributive for each of these two parts. These both have an x in them, so I can take an x out. I have x minus 6. These both have a 36 in them, so I can take a 36 out. I have x minus 6. And then I can rewrite that by undoing distributive again, so I have x plus 36 times x minus 6 equals 0. Now I'm ready for the zero product property. A times b is equal to 0, so I can say, well, maybe x plus 36 equals 0, and that would mean x is equal to negative 36. Or maybe x minus 6 is equal to 0, and that would mean that x is equal to 6. One of these numbers doesn't make sense because we're talking about a dimension. We're talking about how wide that wall is. There's no way for a wall to be negative 36 feet wide. So the only possible answer is x equals 6 because that's the only number that makes sense. So that means that this is a vault with 6 feet wide walls all around it. All right. At this point, I would like you to pause the video and work through this problem. Problem says a swimming pool has a length that is twice its width. That's why we have x and 2x. There is a deck around the outside that has a uniform width of 2 feet. The total area of the pool and the deck that borders it is 96 square feet. What are the dimensions of the pool? So I'm going to pause and have you figure this out. Go slowly and carefully and review the last video if that helps you. Okay, I got that the dimensions of the pool were x plus 4 and 2x plus 4. I know that those two multiply to make 96. I multiply that out, subtract the 96 over, and then everything is divisible by 2, so to make my numbers smaller, I divided by 2. And then I did product sum of negative 40 and 6, broke up my polynomial, factored that, and I got x equals negative 10 or x equals 4. X equals negative 10 doesn't make sense for a dimension, so I'm going to use x equals 4. And then this says, what are the dimensions of the pool? So the pool is 4 feet by 2x, so 8 feet. Those are the dimensions of my pool. Okay, the other thing we can do, I'm just going to back up a little bit. This is a big process, and it takes a lot to get it right, but as you're making mistakes, be patient with your brain. It actually grows your brain to make mistakes and to try things. The only way your brain won't grow is if you don't try it, so make sure you're trying these problems. All right, the other thing we can do with factored form is we can use it as a third way to graph a quadratic. So here's an example of a quadratic that we can graph by factoring. So first what we're going to do is factor. So we're going to do product sum. The product is negative 8. The sum is negative 2. So I noticed that that would be negative 2 times 4. Nope, it wouldn't because that would add up to positive 2. But negative 4 times 2 would work. So we're going to use that. So this becomes x squared plus x squared minus 4x plus 2x minus 8. We can factor an x out of that, so we get x minus 4 out of this part. We can factor a 2 out of this part, so we get 2 times x minus 4. And then this becomes x plus 2 times x minus 4. And we know that for the x-intercepts, either x plus 2 equals 0, so x equals negative 2, or x plus 4 equals 0, or x equals 4. So our x-intercepts are going to be at negative 2 and 4. Okay, for the line of symmetry is going to be halfway between those 2 points. You can either find that by counting, or you can find it by taking the average of the two x-intercepts. So 4 plus negative 2 divided by 2, because that's how you average two numbers. That would be 2 divided by 2. So the line of symmetry is going to be x equals 1. So that means that our parabola has a line of symmetry at x equals 1. And now to figure out the vertex, we're going to plug x equals 1. You can plug it either into this type of equation, or I think it's actually easier to plug it into the factored form. So if I plug 1 in, I have 1 plus 2 and 1 minus 4. I'm looking at the factored form here. So that would be 3 times negative 3. And so my vertex is at 1 comma negative 9. I know that the vertex is on the line of symmetry, so I know that the x-coordinate is 1, and then I find the y-coordinate. It's a little off my graph, so it would be down here somewhere. And that means that my quadratic looks like this, passing through my two x-intercepts, and then also meeting at the vertex. So the tip for graphing a quadratic is first you factor, then you graph the x-intercepts, and then you find the line of symmetry. You add the two x-intercepts together and divide by 2. And then you plug that number in for the line of symmetry to find the vertex. It would have worked to plug x equals 1 into the original form of the quadratic, but I actually think the math is easier if we use the factored form of the quadratic. I'm going to let you try this one. I want you to be aware that you're going to have decimals for this problem, so feel free to grab a calculator. I'm going to let you pause the video, so please pause, and then return after you've done the problem. Okay, you notice with this one that our line of symmetry is halfway between 1/2 and negative 3. So this is an example of when doing the average might be easier than just counting where the middle is. If you add the two together and divide by 2, that gives you the average. So your axis of symmetry is at x equals negative 1.25, and then you plug that number in to get that your vertex is at negative 1.25 comma negative 6.125, and I just estimated where that was on my graph. I know it's not perfect, but that gives me the shape of my parabola. Okay, the other skill we can have is we can extend that a little bit and write the quadratic function from the graph. The way we do that is keeping in mind that when we have the x-intercepts, our parabola might be very steep. It might be upside down. So the only thing we don't know if we have our x-intercepts is we don't know what a is. Remember, a tells us how steep our parabola is. So what we do is we write this so that it looks like a times, this would be x plus 5, because remember we subtract to figure out that it's negative 5. And this would be x minus 1, because we subtract to figure out that, we add 1 to figure out that it's positive 1. But we just don't know what a is. So the way we figure that out is we say, well, we know this other point on our parabola. We're going to use that other point to figure out what a is. And our other point is at x equals negative 2, so we're going to use negative 2, and our answer would be negative 9, because that's our y-coordinate. So a times negative 2 plus 5 times negative 2 minus 1. So negative 9 is equal to a times 3 times negative 3. So negative 9 is equal to negative 9a. If we divide by negative 9, that means a is equal to 1. So knowing that a is equal to 1, the factored form of our parabola is going to be just x plus 5 times x minus 1. You can write a 1 here if you want to, but you certainly don't have to. All right. This is a summary of where we went this section. We used the factored form to find the x-intercepts. We graphed the x-intercepts and then figured out where the vertex would be. We also worked on factoring to find the zeros. Those are going to be solutions to our equation. We made sure we moved anything over to the left-hand side so that we didn't have any, we were equal to 0. And that's our lesson for today.